So today's lesson is on ratios and similar polygons, and we're going to actually talk specifically about triangles today, okay? So here's our first page. So 4.4, it says figures that are similar have the same shape but not necessarily the same size. And we talked about this a couple days ago when we talked about similarity on Monday. The symbol for similarity is that's the same symbol that would be at the top of a congruence sign, okay? So when we talk about corresponding angles are equal, so notice that angle X, Y, and Z are congruent here, X, Y, Z, X, X, Y, Z, okay? So we are looking at that, but then when we talk about sides, now I'm going to give you all a little hint here. So when I do this, I like to look between things that are the same. So if I look between Y and Z, that's where my A is, right? So I'm going to put one dot there, so Y and Z there, so Y and Z there, and Y and Z here. So I put one dot on that, so that tells me that A is related to D and A is related to P. Y'all see this? So A is related to D there and A is related to P there. So I'm going to create a ratio of that. Then I'm going to talk about B. So B, I'm going to put two dots on this side. Now that doesn't mean that these sides are congruent. They're not, but they do have a relationship because they are between angles X and Z. Again, between angles X and Z here and between angles X and Z here. Okay, so once again, you should notice that we have B over E, right? And we have B over Q. You see that? B over Q there, okay? So now when we talk about the last side, I'm just going to put three dots on this. Again, this doesn't mean they're congruent. That's why I'm putting dots and not tick marks, because this is a way for me to relate these sides to one another. So this one's between X and Y. F is between, C is between X and Y, F is between X and Y, and R is between X and Y. Can y'all see that? Okay, so that's why I put three dots on that side. So again, we've got C over F and we've got C over R, okay? So as we work through this, we're going to do the same thing here. So we're going to talk about our first pair of sides. So you notice we have this right angle and one arc. So I'm going to put a dot there. Right angle, one arc, and a dot there. So that's 3 over 6, right? Well, you can reduce that, or you can just work with the 3 over 6. I'm going to go ahead and reduce it because I think it'll be easier to work with as I move through the problem. Now I'm going to look at my X side. So this side is from a right angle to nothing. So here we're looking from the right angle to nothing, okay? So when we work this problem, we're going to relate these sides to each other. Then we're going from one arc to nothing. That's going to be my 3 dot side. And from one arc to nothing, again, the 3 dot side. Okay, so now we're going to use the ratio that actually has a number on both top and bottom to help us set up the rest of the problem. So we're going to set that 1/2 ratio equal to our 2 dot, which is X, over our 2 dot, which is 8. Okay, now to do these, hopefully you remember how to do these. We cross multiply. Do y'all remember how to do this? So we're going to say 2x equals what? 1 times 8, okay? So that's going to be 2x equals 8. We're going to divide both sides by 2. So our x is equal to 4, okay? We're going to check this in a minute, but we're going to keep working. So now we're going to use that same ratio we got in the beginning, the 1/2. So we're going to use, again, our 1/2 is equal to, this time, our 3 dot side. So our 5 over our y. So same process we used just a second ago. We're going to cross multiply again. So we're going to do the 2 times the 5 and the 1 times the y. So we're going to go 2 times 5, and that's equal to 1 times the y. So that's going to be 10 is equal to y. So now we've solved for our x and a y. Now what I want to do is check these to see if they're right, okay? So what we should be getting is the same ratio. So when we take this x over that 8, now we have what? 4 over 8. And that is equal to 1/2, so that checks out, okay? And we're going to do the same thing with this 5, and we're going to put it over the 10, because that was what we got for y, right? So we're going to go 5 over 10, which is also equal to 1/2, so that one also checks out, okay? So let's see if you guys can do the U-try. Pause the video and come back to me when you're done. Okay, so we're going to do this the same way we did the other one. We're going to step it out, okay? So I'm going to do this 1 dot side here. The 5 is between the arc and nothing. The arc and nothing here is the 7.5. Then we've got what do y'all want to do? This other side right here. So let's just do y. So we're going to do nothing, 2 arcs to nothing. So what has 2 arcs to nothing here? That's our 12, isn't it? Okay, and then we've got, obviously this has got to be our third side, right? 3 dots there, 3 dots here. Okay? So again, let's see, where do we have a relationship? Where do we have 2 numbers? That's what we're going to look for here. So we see this 5, the 1 dot there, and the 7.5. Now this isn't always going to work out for y'all like this, okay? Where our 1 dot is the one that actually has the existing ratio. So now this time I'm just going to leave it 5 over 7.5, and I'm going to set that equal to, because I could reduce that, but I don't know what it reduces to. The other one I can see very easily what it reduced to, but we can leave it just like this too. We could have left the other one 3 over 6. Okay, so now let's look at our 2 dot. We've got a y on the left, and what do we have 2 dots on the other one? A 12, right? So once again, we're going to cross multiply. Okay, so we're going to do this. That's going to be 7.5y, and that's going to be equal to what? 5 times 12. Okay, so that's going to be 7.5 is equal to 60. Sorry, y. So we're going to divide both sides by 7.5. So our y is going to be equal to, I got 8. Okay, so we're going to talk about these ratios in just a second. Okay, so just hold on 1 second. All right, now let's do the other one. So we're going to use the same ratio, that 5 over that 7.5. And now we're going to look at our 3 dot side. So now we got a 9 over a what? Z. So once again, we're cross multiplying. So we're doing 5z is equal to 9 times 7.5, okay? So 9 times 7.5 was 67.5. So we got 5z is equal to 67.5. So then we're going to divide both sides by 5 here. So we got z is equal to, I got 13.5. Okay, now we want to compare these ratios, okay? So if I take this original one, the 5 over the 7.5, and I put that in my calculator, I get 0.667. It rounds to that, right? Now we're going to keep trying these and see what we get. So now when we do our 2 dot one, we got our y, which is 8 over our 12, right? So I'm going to do that one. 8 over 12, guess what that is? That's also equal to 0.667. So again, remember what we're looking for here is the same ratio for all 3. If we don't get the same ratio, then we are in trouble because we did something wrong. Okay, so up here, then our y, no, our z. So yeah, our 3 dots. So we got 9 over 13.5. Okay, and guess what that equals? 0.667. So all of these checked out, okay? They are all the same ratio, and that's what we're looking for, okay? All right, so the next one says the similarity ratio is the ratio of lengths of the corresponding sides of 2 similar polygons. The similarity ratio of triangle ABC to DEF is 3 over 6, or 1/2. The similarity ratio of DEF, so if I go from the smaller one to the bigger one, then, from the ABC to DEF, we're always going to put where we ended over what we began. Remember we talked about this the other day? So we're going, this is old and this is new, right? So our old number was 3 and our new number was 6. So we're going old over new. Y'all remember how we talked about this the other day? Now if we go DEF to ABC, it's the other way around, right? So that time, if we start with DEF, it's our old and ABC's our new, okay? So it says, write a similar statement is like writing a congruent statement. Be sure to list the corresponding vertices in the same order. Now for this one, it's pretty hard because obviously everything's, the congruent angles. That's not going to help us. But as we start to work through these, we're going to actually look at angle congruent statements to help us write our similarity statements like we did with congruent statements, okay? So it says, determine if the triangles are similar. If so, write a similarity ratio and a similarity statement. Step 1 is to identify the pairs of congruent angles. So that's what we're going to do first. So it shows us that angle L right here has 1 arc, right? And what over here is 1 arc, P, right? So we're going to put L as congruent with P. And then we have a right angle at M and we have a right angle at N. So by the third angles theorem, the one that has nothing on it, J, and the one that has nothing on it, S, these have to be congruent, right? So now there's a couple ways we could proceed here. So once again, if you guys notice, we have, and this is the why I like to do this. So we have our shortest side, our middle side, and our longest side, and our longest side. So you remember my dots that I used on the other one? So they're still relevant here, okay? So now what I can also do is I can go ahead and write my similarity statement because I saw three angles that are congruent, right? And so I can say that triangle JLM, look at J had nothing, so what has nothing on the other one is S. What L had one arc, so what has one arc on the triangle on the right is P, and then M was right angle, so this is N. Okay, so now if we write that statement first, we can then use it to write the previous step. So JM, or we can use what I did, which was JM is congruent to SN. So we're going to just take those numbers. JM was 45, right? And SN was 18. Now, in your calculators, you guys can reduce this. Hopefully, you guys can see that 9 goes into both of those, right? So 9 goes into 45 5 times, and 9 goes into 18 2, so 5 over 2. Now, what should occur here, if these are actually similar, is we should get the same ratio for all of them. So ML has 2 tick marks, or 2 marks on it, so it's 60. And that should map to our NP, right, which is 24. So this time, again, 12 goes into both of those, so 5 and 2 again, right? Same ratio again, okay? So then we got LJ. LJ is 75, and that's got 3 dots on it, and PS has 30. And this time again is 15. 15 goes into 75 5 times, and it goes into 32 times. So we got the same ratio 3 times, and our similarity ratio is 5 over 2, which could also be written 5 to 2 like that, or 5 to 2, okay? Those are the different ways you can write the similarity ratio, okay? So because we got the same similarity ratio for all 3, we can say that these 2 triangles are congruent, okay? So here's our next one. Let's see if you guys can do this one. Pause the video. Come back to me when you're done. All right, it says determine if the triangles are similar. If so, write a similarity ratio and similarity statement. Identify the pairs of congruent angles by the corresponding sides. So angle N is a right angle, so it goes to Q, right? Angle P is 63 degrees, and angle R is 63 degrees, right? And then by the third angles, obviously M and T have to be congruent, right? So again, we could go ahead and write our similarity statement, or we can go ahead and proceed with what we did before. So notice our smallest side is 0.5, smallest side is 1 over here. Then we've got our 1 and our 2, and we've got our 1.1 and our 2.2. Now again, notice I'm doing these dots. They just help me relate the sides to each other. Smallest, middle, largest, okay? So now we've got MP over TR. Okay, now I want y'all to look again. So if we said MNP is congruent, or similar, sorry. MNP is similar to what? We started with the nothing, and then this we have, so that would be T. And then we had the 63, so no, we went to the right angle, so this is Q. And then we went to 63, right? Which would be P and R. There we go. Okay. Now, again, if we didn't have those statements up there, the MP, notice first and last, is TR, first and last, okay? So MP was 2.2, and this one's 1.1, and what does that reduce to be? 2 over 1, right? MN was 2. TQ was 1, so that's still 2 over 1, right? And then we have NP, which was 1 over 0.5, and so this is still 2 over 1. Now let me give you all a little trick here. So this is good. Our ratio is going to be 2 over 1. Got the same ratio for all 3 sides, so that's why we can say that these triangles are similar. If you don't get the same ratio for all 3 sides, you cannot say they're similar, okay? There was something else I was just thinking of, but I forgot what it was, so oh well. All right, so here's the next one, example 3. It says, determine if the triangles are similar. If so, write a similarity ratio and a similarity statement. Identify the pairs of congruent angles. So both of these triangles, y'all notice these two sides. We got a 10 there and a 10 there, and we got a 5 there and a 5 there. So these are what kind of triangles? Isosceles triangles, right? Because two sides are congruent in each of the triangles. So what we want to do, so that we know then that P is congruent to R here, and we know that S is congruent to W, right? That's what we know. So P is congruent to R, and S is congruent to W, okay? So now what I want to do is I want to find out what P and R are. Okay, so let's go 180 minus the 36. We just did this, right? So I'm pretty sure that's 144. So then we want to divide that by 2. So that means that's 72 degrees, right? So that means this angle right there is 72, and that angle right there is 72. Well, I'm already suspicious that this isn't going to work because we have a 62-degree angle over there on the left, and this one would also be 62, right? So this time we're going to do 2 times 62. That's going to give us 124, right? And then we're going to subtract that 124 from 180. And what's that going to give us? I got 56, okay? So remember, our first rule that is going to determine whether two shapes are similar is that the angles have to be congruent. So here's the deal. They are not similar, and y'all already have this written on your paper, but we're going to write it again. They're not similar because they are not congruent. Y'all see that? The angles are not congruent. So let's say this. Angles not congruent. How about that? We'll write angles not congruent. Angles not congruent. And again, that's already written on your paper, but I would write it again because it is the key. Angles have to be congruent for shapes to be similar, okay? Then remember, for polygons to be similar, corresponding angles must be congruent, and corresponding sides have to produce the same ratio. They have to be proportional. When you work with proportions, be sure that ratios compare corresponding measures, okay? So on this next one, this is a little different. It says, given that EB is parallel to DC, so it tells us that EB is parallel to DC. Then angle A would be congruent. Obviously, we're going to look at two different triangles here, y'all. So I want you to see the two triangles we're going to talk about. We're going to talk about this triangle right here. And we're going to talk about this big triangle right here. Okay, that's the relationships we're about to talk about. These two triangles, okay? So just for the sake of y'all talking. So do you notice that angle A is in both triangles? It is. It's in the little triangle and the big triangle, right? So we're going to be talking about triangle AEB. Is it similar? This is the question we're going to ask ourselves. Is it similar, question mark, with triangle ADC? Okay? So angle B would be congruent with what angle, y'all? This angle right here would be congruent with what angle? It would be congruent with C. Why? Because they're corresponding angles, aren't they, y'all? And you guys should remember that from early on in the year. And then we're going to look at angle E up here. This angle right here. Angle E is congruent with what angle? Angle D. Now, that could be congruent because of the third angles theorem. Or, why else would it be? Could it be congruent? Corresponding angles again, right? You got it. Okay. All right, so then I want you guys to look, because this is going to get a little tricky here, because I'm going to erase this. So we know that they are going to be similar because we have three angles that are congruent. Y'all got me? So now what we want to do is figure out what the scale factor is. So find the unknown lengths, it says. So we notice we have AB here, right? And then we have AC. You see it? So what is AC, guys? What is the length of AC? That would be 12, wouldn't it? Okay. And the way we got that is by adding together AB and BC, right? So 4 is the length of AB. We got that right there. 4, yes, 4. Got it right there. But then 4 plus, this would be 4 plus 8, which is what? 12. Y'all see that? And then that reduces to be 1/3. Agreed? 4 goes into 12 3 times, okay? Now, here's the rub. We should get the same ratio for all of them, okay? And this is really the key. So the next one, we're going to color code these guys just to help y'all out. So we got AE is over what? That whole thing. So wouldn't we add those two things together to get that? So that would be what? X over x plus 10. Would you agree? Now, here's the deal. This is the way we're going to figure out what these values are. So this time, we're going to take this 1/3 that we have right here, and we're going to put it right there. So that's going to be 1/3 is equal to, and we're going to make that equal to our x over x plus 10. Now we're going to solve this. Remember how we do this? We're going to cross multiply, right? So that's 3x, and that's equal to 1 times x plus 10, right? So that's going to be 3x is equal to x plus 10. So we are going to subtract x from both sides. So that's going to give us 2x equals 10. So what is x equal to, y'all? Divide both sides by 2. So x is equal to 5. Okay? We're going to check this in a minute. Okay? So just hold on. Then we got EB. So this one's a little easier because EB is right there. That's 3, right? And then there's our CD, right? So again, we're just comparing sides, right? Okay, so this time we are going to put y there, right? So again, we're going to set this up like we did the last one. So this is going to be 1/3. Let me just put it in the same color we did the last one. So this is our original ratio, right? 1/3 is equal to 3 over y. So again, we're going to cross multiply. So that's 1 times y is equal to 3 times 3. So that means y is equal to 9. Okay, so now I'm going to stick these back up in here so we can talk them through, okay? So this is telling me that this is 5, and we said that this was 9, right? So now, to check these, this is what I want you guys to look at. So our original ratio was 1/3, yes? So that's what we should be getting when we compare. So this is going to be 5 over 5 plus 10, which is 15, right? So 5 over 15, guess what that reduces to be? 1/3. So that one checks out, right? Then we've got our 3 right here, 3 over 9, which also reduces to be 1/3, and so that one also checks out. And remember, you got to get the same ratio for all 3 sides. That's the key. So now we got some practice for you guys. So go ahead and try these and come back to me after each one, okay? All right, so this first one says find x. So notice again, I've got a little triangle up here, and I got a big triangle there, right? So you guys see that 5 over 15? That's going to be equal to 8 over, remember, we got to add those two together to get the whole side. So that's going to be 8 plus x, right? Cross multiply, 8 times 15. What am I doing? Can't write, y'all. 8 times 15, and I got that again right there, is equal to 5 times 8 plus x. Do y'all remember the distributive property? Hopefully. So 8 times 15 is 80. And that's equal to 5 times 8 is 40, and then 5 times x is 5x, right? So we're going to subtract 40 from both sides. Wait a minute, that was 120. My bad. This was 120, y'all. I looked the wrong place. So then we're going to subtract 40 from both sides. That's when we're going to get 80 is equal to 5x. We're going to divide both sides by 5. So x is equal to 16. Okay, now let's talk this through. Okay? So if this is 5 over 15, 5 over 15, is that going to be equal to 8 over, okay, that's 16. Add those two together. 8 over 24. That's 1/3 because 5 goes into 15 3 times and 8 goes into 24 3 times, right? So yes, they are equal. That's how you guys can check it, okay? So again, pause me and then do you try 4. So once again, we're doing 12 over 20 equals 9 over 9 plus z. Cross multiply, 20 times 9 equals 12 times 9 plus z. We're using the distributive property again over there on the right. This is going to be 180 is equal to 108 plus 12z. Subtract the 108 from both sides. So that's going to give us 72 is equal to 12z. Divide both sides by 12. So what is z equal to, y'all? Z is equal to 6. Okay, so let's see this again. Let's double check it. So if this was 6, so that's going to be 12 over 20. Is that equal to 9 over 9 plus 6, so that's going to be 12 over 20. And again, you can just check this in your calculator, right? 9 over 15. So, and that is 3/5 and 3/5, isn't it? So that's 3/5. Or you guys could see 0.6 in your calculator, right? So this could be 0.6 is equal to 0.6. Either way, it checks out, and that's what we're really trying to look for, okay? All right, we've got a couple more. So this time, this is a little different, right? So this one, you should be able to see that we have congruent angles here. Now, this is the one where we're going to want to put our dots, right? Okay. So we've got our dot here. So we're going from an arc to a right angle, an arc to a right angle, right? Then I'm going to put 2 dots from our right angle to nothing, our right angle to nothing, right? And then we've got our arc to nothing. I'm going to put my 3 dots here. And our arc to nothing, our 3 dots here. Now this is going to help me relate these sides to each other. So let's see if we can find a pair of sides that has measures. I see 5 over 10.5. We're going to set that equal to, and let's just go with our 2 dots, 12 over Q, right? So cross multiply again, that's 5Q is equal to 10.5 times 12. So 10.5 times 12 is 126, so that's 5Q is equal to 126. We're going to divide both sides by 5. So Q is going to be equal to 25.2. Whoops. Oh my gosh, I cannot write, y'all. It's supposed to be 25.2. Okay, now let's do the other one. So we're going to use that same ratio, 5 over 10.5, and we're going to set that equal to now our 3 dot one, right? So we're going to go P, maybe if my pen works, P over 27.3. So we're going to go 10.5 times P is equal to 5 times 27.3, okay? So multiply 5 times 27.3, I got 10.5 P is equal to 136.5. Divide both sides by 10.5. So I got that P was equal to 13. Again, now how can we check this? We're going to actually check our ratios, okay? So 5 over 10.5. I did this, I reduced it, y'all, and that was 10 over 21. And if you guys have a TI-84, just push math in 1 and it'll tell you what that is. And if not, then just tell me so what I got when I did this was 0.47619. Now, what I'm looking for is, do I get the same ratio with all 3, right? So now let's try this. Let's try P. Okay, so that's going to be 13 over 27.3. Actually, let's do Q next. So Q is going to be 12 over 25.2. Put that in your calculator. Got the same number, 47619. And then our last one, same thing, right? So this time we're doing P, and I'm going to look up here. P was on top, so that's going to be 13 over 27.3. And again, when I put that in the calculator, got the same number, and that's what you're looking for, okay? If you don't get the same number, then obviously the ratio is not the same, and they are not going to be similar, okay? So, and that's what you're doing to solve, okay? So here we go again with this one. Let's start with the 6. I'm going to put 1 dot there and 1 dot there because that's between 1 and 2 arcs, 1 and 2 arcs. I'm going to go 1 to nothing, put 2 dots here, 1 to nothing, 2 dots there. Then I'm going to go 2 to nothing here and 2 to nothing here. So 1, 2, 3. Now, do y'all see why I do those dots? They really help me a lot to be able to set up these sides. So I'm going to look at, what do we have? So 6 over B is equal to, I think our 3 dot side is the one we're going to have to use, y'all. 7 over 22.4. So once again, cross multiply. 7B is equal to 6 times 22.4. So 7B is equal to 6 times 22.4 is 134.4. Divide both sides by 7. B is going to be equal to 19.2. We'll check it in a minute, okay? All right, so let's do this other one. So we're going to do the other one. So I'm going to use this ratio again, 7 over 22.4, because that's where our numbers were, right? And we're looking for numbers that we can set up. And this time we're going to solve for our a. So we're going to go a over 32, right? So that's going to be 22.4a is equal to 7 times 32. 7 times 32 is 224. So this is 22.4a equals 224. Some of y'all can see the answer already. Divide both sides by 22.4. So a is equal to 10. Okay, now we're going to check it, okay? So once again, we're going to compare sides. So 1 dot to 1 dot. So that's 6 over, so we've got our 6 over 19.2. 6 divided by 19.2. 6 divided by 19.2 is, this is 0.3125, okay? So let's keep going. Then we've got our ratio, the 7, right? This one. So let's do this one. 7 over 7 divided by 22.4 was, guess what? Same thing, 0.3125. And then our last one is our a, which is our 10 over our 32, right? And guess what? 10 divided by 32 is also equal to 0.3125. And remember, that's what we're looking for, same ratio, okay?